What if I told you a 2-liter Honda engine, something you'd find in a Civic, could make over 1,000 horsepower? Not with nitrous. Not for 5 seconds before exploding. But reliably, repeatedly on pump gas, mixed with E85. This is the story of the K02A, the 4-cylinder that rewrote the rules. Picture this. It's 2001, and Honda just unveiled their new K02A engine in the Japanese market Integra Type R. The automotive world yawned. Another VTEC 4-banger, another 220 horsepower screamer. Been there, done that. But hidden beneath that familiar Honda valve cover was an engineering revolution that would take over a decade to fully understand. This wasn't just an evolution of the legendary B-Series. This was Honda's secret weapon, an engine so overbuilt, so perfectly designed for forced induction that it would eventually embarrass supercars costing 20 times as much. The K02A represented Honda's most ambitious 4-cylinder project ever. The success of the B-Series engines that dominated import drag racing through the 1990s, Honda's engineers were given a blank sheet and a simple directive: create the ultimate 4-cylinder platform for the 21st century. What they delivered would become the most shocking success story in modern engine building. To understand why the K02A shocked everyone, we need to travel back to the late 1990s. The import tuning scene was exploding. Honda's B-Series engines were the kings of 4-cylinder performance, with B16s and B18s making 400, maybe 500 horsepower in extreme builds. That was considered the ceiling for a street-driven 4-cylinder. V8 guys laughed at the idea of a 4-banger making real power. No replacement for displacement was gospel. The fast guys had big block Chevys or twin Supras. 4-cylinders were for fuel economy, not horsepower wars. But Honda's engineers in Tochigi were planning something different. They knew turbocharging was the future. They knew their customers would push any engine they built to the absolute limit. So they designed the K02A with a secret agenda. It looked like a naturally aspirated engine, but every design decision was made with forced induction in mind. The problem Honda faced was complex. They needed an engine that would pass emissions, deliver Honda reliability, rev to the moon for their Type R models, and secretly be capable of handling massive boost pressure. Previous Honda engines were designed for natural aspiration first, with turbo builds requiring extensive modifications just to survive. The B-Series needed sleeve upgrades, sometimes even block modifications to handle serious boost. Honda wanted to eliminate those limitations from the start. The development began in 1998 under project leader Kenichi Nagahiro. His team studied every blown B-Series engine, every failure point, every limitation. They reverse-engineered the requirements for a 1,000 horsepower engine, then disguised it as a 200 horsepower economy car motor. The budget was enormous, over 2 billion yen just for the engine program. Honda's board thought they were funding the next Accord engine. They were actually funding a revolution. The foundation started with the block. While everyone saw another aluminum Honda 4-cylinder, the details told a different story. First, the deck height was increased to 231.5 liter, allowing for longer rods and better rod-to-stroke ratios. The cylinder walls were lined with cast iron sleeves from the factory, not the fiber-reinforced metal sleeves of the B-Series that would crack under high boost. These iron sleeves could handle cylinder pressures that would grenades lesser engines. But here's where Honda got clever. They used a closed-deck design where the top of the block was reinforced with material bridging between the cylinders and the outer walls. Most manufacturers used open-deck designs for better cooling. Honda prioritized strength. Under the block, they added a bed plate, essentially a girdle that tied all 4 main bearing caps together into one massive structure. This turned the bottom end into something closer to a race engine than a street motor. The crankshaft was forged steel in the Type R variants, not cast iron like most economy engines. The connecting rods were also forged in performance models, with a design borrowed from Honda's Formula One program. The pistons were cast in base models, but forged in Type R specs, with valve reliefs that accidentally left room for much larger valves and higher lift camshafts than Honda ever intended to sell. The head design was even more revolutionary. Honda introduced what they called IV Tech, intelligent variable valve timing and lift electric control. This wasn't just the old VTEC system of two cam profiles. This added continuously variable cam timing on the intake side. But the real genius was in the port design. The intake ports were massive, almost race engine massive. The exhaust ports were equally impressive. Honda claimed it was for emissions and efficiency. Tuners would soon discover it was perfect for flowing massive amounts of boost. The combustion chambers were designed with an 11.5.1 compression ratio in most variants, high for natural aspiration, but still boost-friendly with proper tuning. The valve angles were optimized for flow, not just swirl. The spark plug location was centered for optimal flame propagation, even under boost. Every decision pointed to the same conclusion. Honda knew exactly what people would do with these engines. Initial reception was lukewarm. The K02A made 220 horsepower in the DC-5 Integra Type R, 200 horsepower in the base RSX, and as little as 160 horsepower in economy-focused variants. Car journalists praised the high-revving character, but complained about the lack of torque. The B-Series faithful were skeptical. Why fix what wasn't broken? Early adopters found the K-Series harder to work on, with the intake on the front instead of the back, and accessories cluttering the exhaust side. But then the tuners got serious. The first breakthrough came from Honda, who cracked the ECU and discovered something shocking. Honda had built-in provisions for boost in the factory computer. Not officially, of course, but the tables were there. The sensors were capable. It was like finding secret rooms in a house you'd lived in for years. Inline performance was among the first to push boundaries. Their 2003 build took a K02A2 from an RSX Type S, added a Garrett GT35R turbo, and immediately made 516-wheel horsepower on the stock internals. The engine that Honda rated at 200 horsepower was making 2.5 times that power without opening it up. The tuning world collectively lost their minds. But that was just the beginning. Tuners discovered the K20 head would bolt onto the K24 block, creating a 2.4-liter monster with the best of both worlds. The K24's displacement and torque with the K20's high-flowing head and VTEC system. This Frankenstein K24-K20 combination became the foundation for the most shocking builds. Let's talk about the first documented 1,000 horsepower K-Series build. Golden Eagle Manufacturing achieved it in 2009. Their setup started with a K24 block, bored and sleeved to 2.5 liters. They used custom 13.1 compression pistons, yes, 13-to-1 with boost, and a precision 7675 turbocharger, custom cams with .650 lift. Dual valve springs rated for 12,000 RPM. The result? 1,018 horsepower at 9,660 RPM on 45 pounds of boost. The key to these power levels was the head flow. Stock, a K02A head, flows about 290 CFM on the intake at 500 lift. That's impressive for a factory head. But with porting, that number jumps to over 340 CFM. To put that in perspective, a traditional small block Chevy head flows about 250 CFM stock. The K02A was outflowing V8s with half the cylinders. The valve train could handle the RPMs too. Honda's VTEC system, originally designed to let the engine rev to 8,600 RPM safely, proved capable of so much more. With upgraded springs and retainers, K-Series engines were spinning to 10,000, 11,000, even 12,000 RPM. The factory rod bolts were good to 9,500 RPM. The oil pump kept pressure to 10,000. It was like Honda had accidentally built a Formula One engine and detuned it for the street. By 2012, 700 horsepower K-Series builds were almost common. Garrett Motion documented a street-driven K24 making 775 wheel horsepower, full interior, air conditioning, daily driven. The owner put 30,000 miles on it at that power level with nothing but oil changes. The B-Series guys were in shambles. Their legendary B18C needed extensive work to make 600 horsepower reliably. The K-Series was doing it with bolt-ons. The supporting technology evolved rapidly. Honda's K-Pro engine management became standard, offering laptop tuning and advanced features like boost-by gear and traction control. Fuel systems grew from 1,000 cc injectors to 2,000 cc monsters. Turbo technology advanced from journal bearing to ball bearing to billet wheels. Every advancement pushed the power ceiling higher. Let me break down a typical 1,000 horsepower build in detail. You start with a K24 block, preferably from a TSX for the stronger internals. Bore it 0.95 mm over and sleeve it with Darton or LA sleeve modular iron sleeves rated for 1,500 horsepower. These sleeves are about $2,000 and require precision machining, but they're the foundation of big power. The rotating assembly gets serious. Custom pistons from CP or JE, typically 9.5.1 compression for pump gas or 10.5.1 for E85. These run about $800. Connecting rods from Manley or Carrillo, rated for 1,000 horsepower, another $200. The factory crank is actually good to about 900 horsepower, but most builders go with a Callies or Weinberg piece for insurance. That's $2,500 right there. The head needs work too. Port and polish adds about 20% more flow, worth 100 horsepower at these levels. Faria or Supertech valves, +1 mm on the intake, stock size on the exhaust. Dual valve springs from Supertech rated for 0.650 lift. Titanium retainers to handle the RPM. Custom camshafts from Kelford or Toda with duration in the 280-degree range. The head package alone is $5,000 in parts plus machine work. The turbo system is where things get serious. For 1,000 horsepower, you need something like a Precision 7685 or Garrett G42 1200. These turbos flow enough air for 1,200 horsepower. The hot side uses a T4 divided housing. The cold side features a 5-inch inlet. Spool time, with proper gearing, full boost by 5,000 RPM. The turbo alone costs $3,000. Supporting mods, multiply quickly. Fuel system needs 2,150 cc injectors, $1,600. Fuel pumps, 3 Walbro 450s or a Weldon 2345, another $1,500. Intercooler, big enough to cool 45 pounds of boost, $1,200. Exhaust manifold from full race or dock race, $1,800. Wastegate, preferably dual tile 44mm units, $1,400. The turbo system complete is easily $15,000. But here's the shocking part. Even with all these modifications, the basic architecture remains Honda. The deck surface is stock. The cam towers are stock. The water pump, oil pump, alternator, all stock locations. You can build a 1,000 horsepower engine and still use factory motor mounts. Try that with any other platform. The first time a K-Series broke into the 7s in the quarter mile, it changed everything. Jesus Padilla's K24-powered Toyota Starlet ran 7.88 at 175 mph in 2015. The car weighed 1,800 pounds with driver. The engine made 100 wheel horsepower. A 4-cylinder Honda engine was running times that used to require a big block V8. The drag racing establishment didn't know how to react. By 2018, the record fell to 7.43 seconds at 196 mph. A naturally aspirated pro stock car with 500 cubic inches runs low 7s. This Honda had 2.5 liters, 152 cubic inches, with a single turbo. The power per liter was approaching 500 horsepower. Formula One engines from the turbo era made 300 horsepower per liter and lasted one race. These K-Series were making more and lasting seasons. The technology trickled down to street cars in shocking ways. Time attack cars started showing up with 800 horsepower K-Series engines. Not trailer queens, cars that drove to the track, set records, and drove home. The Life Motorsports Civic set lap records at multiple tracks with a 900 horsepower K24. Full aero, full interior, street legal. Engine builders pushed further. 4-Piston Racing built a K-Series making 1,400 wheel horsepower. Drag Cartel touched 1,500. The limit seemed to move every year. Builders discovered the factory water jackets could handle 60 pounds of boost with proper head studs. The oil system could support 11,000 RPM with upgraded bearings. Every assumption about four-cylinder limits was shattered. The influence spread beyond Honda. Mazda engineers studied the K-Series when designing the Skyactiv engines. Toyota's development team for the FA20 admitted to benchmarking the K02A. Even GM engineers were caught at SEMA measuring K-Series builds. The engine had become a reference point for the entire industry. But the real shock was accessibility. You could buy a used K24 for $500 from a junkyard, add $20,000 in parts and labor, and you had a 1,000 horsepower engine. Compare that to a built-2 JZ GTE at $40,000 or a racing V8 at $50,000. High school kids were building 10-second cars in their driveways. The democratization of horsepower was complete. The K-Series changed automotive culture. Suddenly, displacement didn't matter. Cylinder count didn't matter. Country of origin didn't matter. What mattered was engineering. Smart engineering. Honda had proven that with the right design, the right materials, and the right execution, a tiny four-cylinder could embarrass anything on the road. Racing sanctioning bodies struggled to adapt. The NHRA created new rules specifically for turbo four-cylinders. Time attack organizations implemented power-to-weight restrictions. Drag strips had to upgrade their safety equipment because cars that looked like economy sedans were running 200 mph in the quarter mile. The failures taught valuable lessons, too. Early builds discovered the oil pump gear could shear above 10,500 RPM. Solution? Billet gears from Boundary or Kenny Benson Racing. The valve springs would coil bind at extreme lift. Solution? Custom springs with progressive rates. The factory head bolts would stretch under extreme boost. Solution? ARP L19 studs torqued to 125 pound-feet. Every failure led to a solution, and every solution pushed the ceiling higher. The chemistry of power changed, too. E85 became the fuel of choice for big power. Its 105 octane rating and cooling properties allowed compression ratios and boost levels that would destroy engines on gasoline. A K-Series on E85 could run 30 pounds of boost on stock compression. The same engine on 91 octane would detonate at 15 pounds. Fuel choice became as important as hardware. The ECU technology evolved in parallel. Honda's K-Pro gave way to Haltech Elite, AEM Infinity, and Motec M-Series computers. These systems offered millisecond precision in fuel and ignition control, closed-loop boost control, individual cylinder fuel trim, traction control strategies that put factory systems to shame. The engine was only as good as the computer controlling it, and the computers had gotten very, very good. By 2020, a pattern emerged in successful builds. K24 block for displacement, K20A2 or K20Z3 head for flow, precision or Garrett turbo-sized for the goal, E85 for fuel, K-Pro or better for management, built transmission, usually a dog box sequential. The recipe was proven. The results were predictable. Building a 1,000 horsepower K-Series had become almost routine. But routine didn't mean easy. These builds required precision. Bearing clearances measured in 10,000ths of an inch. Ring gaps calculated for expansion at 1,500 degrees. Valve lash set with the engine at exactly 180 degrees Fahrenheit. One mistake, one overlooked detail, and $30,000 of engine became scrap metal in seconds. The machine shops that could build these engines became legendary. Golden Eagle, Four Piston, Drag Cartel, Speed Factory. Their waiting lists stretched months. Their engines powered record-setting cars around the world. They turned Honda's efficient grocery getter into a giant killer. The cost per horsepower math was staggering. A built K-Series making 1,000 wheel horsepower cost about $30 per horsepower all in. A comparable 2JZ build was $50 per horsepower. A built LS V8 was $40. A Lamborghini Huracan made 600 horsepower for $300,000. That's $500 per horsepower. The K-Series had turned the economics of speed upside down. Today, the K-Series influence is everywhere. You see it at every drag strip, every time attack, every hill climb. The sound is unmistakable, that raspy, angry four-cylinder scream followed by the whistle of a massive turbo. It's the sound of engineering triumph. The sound of assumptions shattered. The latest evolution is the K20C from the Civic Type R, turbocharged from the factory, stronger internals, better flowing head. The community has already pushed them past 700 horsepower on stock internals. The cycle continues. Honda builds an engine, tuners find its limits, then they ignore those limits and double the power anyway. But the K02A and K24 remain the kings. They're proven. Parts are everywhere. Knowledge is widespread. You can build one with your eyes closed because thousands have been built before. The recipe is perfected. The results are guaranteed. Want 600 horsepower? Here's the formula. Want 800? Add these parts. Want 1,000? No problem, just costs more. The philosophical impact runs deeper than horsepower numbers. The K-Series proved that good engineering beats brute force, that efficiency and power aren't mutually exclusive, that a company known for reliability could accidentally build the ultimate race engine. It showed that innovation doesn't always come from exotic manufacturers. Sometimes it comes from the company that builds your neighbor's Accord. The K-Series story is really about potential, hidden, untapped, waiting to be discovered potential. Honda's engineers built better than they knew. They created a masterpiece disguised as an appliance. It took the aftermarket to reveal what they'd really made, the four-cylinder that could conquer the world. When you see a sleeper Civic destroy a Corvette at a stoplight, remember this story. Remember the engineers who overbuilt an economy engine. Remember the tuners who saw potential where others saw impossibility. Remember that somewhere in Japan, Kenichi Nagahiro is probably smiling, knowing his team created something legendary. The K-Series didn't just shock everyone with 1,000 horsepower. It shocked everyone by making that power accessible, reliable, and repeatable. It democratized speed. It proved that with the right foundation, anything is possible. Even a grocery getter engine embarrassing supercars. What's the most powerful K-Series build you've ever witnessed? Drop a comment below and share your story. And if you enjoyed this deep dive into Honda's accidental masterpiece, make sure to subscribe. We're just getting started exploring the engines that changed everything.